Hello everyone. In this video, I am going to explain two important interfaces, comparable interface and comparator interface. These two interfaces are very important from the interview perspective. So, in this video, I will explain in detail about these two interfaces. First, we will take a small example and we will go step by step and we will learn these two interfaces. I am sure by the end of this video you will clearly understand these two interfaces and how to use them. Let us go to an example. Take a array list, add a few strings, and I am displaying them, and you know that there is a method called sort method from the collections class. I am using that to sort these strings, and once sorting is done, I am displaying the strings which are sorted. Let us run this application and see the output. After sorting, the strings added to list are sorted alphabetically. So, have you ever thought how the collections.sort know whether to sort these strings in ascending order? Why it sorted only in ascending order? Why can't it sort as Jahir first, Ramesh second, Praveen third, Charan fourth? Why it sorted only in ascending order? How collections.sort knows whether to sort in ascending only? That is because the string class override the comparative method in the comparable interface. So indirectly we have specified to sort the strings alphabetically in ascending order. That is why these strings are sorted by the collections.sort method in ascending order. Let us see if this same works. This collections.sort can be used to sort the employee objects. Okay, we will take an example. Just like we have done sorting of strings, we will try to sort the employee objects. This employee is a new class which I am defining for my own purpose. There are two variables, one is name and another one is age. There is a constructor with two arguments, and just that's it. We will try to sort these employees. Okay, I am creating two objects, one with one employee name is Harish, his age is 30. Second employee is Satish, his age is 20. I am adding these two employees into the list and I am displaying those two employees first. Okay, Harish 30, Satish 20. These are added into the array list. Now we will sort. We will try to sort this object as we did for the strings. Add them into the oops, we got an error. This is because collections.sort is having no information whether to sort these employees based on age or based on name. In the case of string class already overridden the comparative method from the comparable interface. So in the case of strings, collections.sort is having idea that it has to sort the strings based on the content in the strings. But in this case, since this is a new user defined class, collections.sort is having no idea. It is in dilemma whether to sort these employee objects on based on age or based on name. So this is where we have to use the comparable interface. We have to override when we write a new user defined class, and if you give these objects for sorting, collections.sort is having no idea. How would it know? You have to provide the information whether to sort these employees based on age or based on name. That information we will provide through implementing the through overriding the comparative method from the comparable interface. When your class override the comparative method from the comparable interface, then it is indirectly saying that whenever if you want to sort my employees, use the logic I defined in the comparative method and sort them. So we will try to implement that method. Okay, first we will see what is the method which has to be overridden. Comparable is an interface. It contains following method: compare to. The return type is int, object, obj. Okay, so if this method returns -1, that means this object is less than the object which is passed as argument. If this returns 0, then both objects are equal. If this returns greater than 0, then it means this object is greater than the object which is passed as or greater than in the sense this object will come next. That means in this case arg is first one and object is the second one. Greater than in the sense this object comes after this one. So you have to define the logic by overriding the comparative method in the employee TO class. If you want to sort the employees based on age, let us implement comparable okay. We have to write the logic such that it returns some integer value. Return this dot age minus emp dot age. Typecast so assume that this is one object and this is the second object. So if this dot age minus emp, that means if this employee is having age 30 and the object which is passed as argument is having 20, 30 minus 20 will be greater. That means 10 means greater than, so this object comes after the object which is passed as argument. So can you see the error which appeared previously has gone, because now the collections.sort is having the information for sorting. The collections.sort uses the logic you have provided in the employee table. In this method, you have written logic such that when the employee when two employees are given, if the age of one employee is less than the age of other employee, the age of employee which is having less will come first in the ascending order. So this is the logic I provide. This will be used. If this, I am explaining again, if this method returns 0, that means both objects are equal. If this method returns -1, that means this object comes before this object. If this method returns greater than 0, then means this object comes after this one in the ascending order. So let us run now. Change it to after sorting. Run them. Can you see? Now the objects are sorted based on the age. Okay. So collections.sort now used the implementation, the logic given in the comparative method. So this is the advantage of the comparable. But what if I want to sort this employees based on name? I don't want to sort based on age. I am running again. Run as Java application. Can you see? The objects are sorted based on age. But what if I have a requirement to sort the employees based on the name, not based on age? Then what we can do is, there is another interface called comparator. It contains a method called compare. We will see new class name comparator. Implement comparator. Click on this and say add an implementer. So instead of changing the logic in the employee sorter, we have, if you, instead of changing the logic here, we can define a new class which implements the comparator interface. There is a method called compare. If this method returns 0, then these two objects are equal. If this returns -1, this will come first. This object will come first in the list, I mean in the sorted ascending order. If this returns greater than 0, then this object comes after this one in the ascending order. So define like this: employee emp1 is equal to employee TO org 0, employee TO emp is equal to employee TO org 1. Return emp1 dot compare to of emp2. So as you already know, compare to method returns 0 if these two are equal, 1 dot get name dot compare to of get name. As you already know, string class already overridden the comparative method. This comparative method returns 0 if these two strings are equal, and -1 if this object comes first in the ascending order, greater than 0 if this object comes after this object. So we will use this now. We will comment this one, or we can do something. Collections dot sort emp list. Now what we have to do is, if you don't give the second argument, we can give the second argument new name comparator. If you don't pass any comparator as the second argument, collections.sort uses the logic you defined in the comparative by default. So whenever you pass the comparator, then the logic you define in this class will be used. In this class, what I have defined, I have defined or overridden the compare method such that the employees are sorted based on the name, not based on age. Now see, now we display them again after sorting using name comparator. Now you can see the output. Can you see? First without sorting, next the objects are sorted based on the logic you defined in the comparative, and finally can you see, now the objects are sorted based on the name, not based on age. This is because whenever you pass the second argument, the logic defined in the comparator will be used. So when you have to use the comparator, suppose when you don't have access to the source code, you cannot modify the logic of comparative. In that case, you can go for comparator. And in another case is, suppose I always want to sort based on age, but sometimes I may require to sort based on other properties like name or salary, like that. So in those cases, instead of this is called default implementation or default sorting logic that need to be, this is called something like default, and you don't want to disturb this logic. But if you want to sort the same objects based on other properties like name or salary, then instead of modifying the logic here, define the comparator and pass that comparator as the second argument. Then the logic defined in the comparator will be used. Okay, now what we will do is, finally we can, suppose we will add another property called double salary. Double salary. This dot salary is equal to salary. Past salary also 10,000, 50,000. Now if I want to sort, if I don't want to disturb the logic, see the default logic is to sort based on age. Generally this is called default. That means it always, this logic will be used to the sort objects. But if you have the requirement to sort the objects other than this logic, maybe if you have a requirement to sort the employees based on the salary or based on the name, then instead of changing this logic, you cannot change the logic. This will be taken as a default. So you have to define another comparator, new class, salary comparator, and as you define the logic here, just like here also, here we will return or use this, we will modify the logic to sort based on salary. Return emp1 dot get salary. I think we did not generate the setter and getter methods for salary. Minus emp2 dot get salary. That's it. For now, instead of going for double, or for now we will make it as int, we to simplify, not to overcomplicate the subject. Implement comparator, not comparable. Now we sort the employees. We will try to, instead of name comparator, give salary comparator. After sorting using salary comparator. Now run this and see the output. We have to display the salary Now we will run the modified code. Can you observe? Initially, the logic you defined in the compare to method is used. This is called default implementation. When you want to sort the objects based on different properties, then you have to define the comparator and pass it as second argument. Then that new logic will be used. So when I pass the name comparator, objects are based on names. When I pass the new comparator called salary comparator, now the employees are sorted based on salaries. So finally, the comparative method is in comparable interface. This is called default implementation, but if you don't want to sort based on default implementation, and if you want to sort the objects based on different properties, then you can define a comparator and pass it as the second argument. Then that logic will be used to sort the objects. Okay, basically almost the logic is same. If -1 is written, both objects are the first object, this will come before this one. 0, if this method returns 0, both are equal. If it returns greater than 0, then this object comes after second object. So you have to write logic to return the values appropriately. Hope you understand.